Okay, I'll do it again. Let me recap. What is given in the question? You are told that there is a sphere. The thing now is the radius is increasing at a rate of 0.1 centimeter per second. Take note, since it's increasing, it must be positive. If it's decreasing, it will be negative. Now, first part of the question asks you to find the rate of increase of the surface area. You are able to tell me, oh, if it's the rate of increase of the surface area, it must be dA over dt. But I do not know what is it, I put a question mark. There must be three things you must be able to tell me. We have the first one, we have the second one, there is the third one that is missing. What are we looking at? Surface area of the sphere itself, right? Can you give me the formula for surface area of the sphere again? 4 pi r squared. Tell yourself, this is the subject, the unknown here is r. We will need to differentiate your area with respect to r. So in this case, dA over dr will give us 8 pi r. Okay, we have our three information, we can get started already. For information, by differentiating this, you get a 1 mark. Any differentiation you do, you will always get your first mark. Now, we are going to make use of the chain rule to connect all these three together. Start with which one? Start with which one? We do not start with the one that deals with the rate of change. We start with the one that doesn't deal with any rate of change itself. So, let's start with dA over dr. Alright? What is at my numerator? dA. So, numerator, rate of change for A must be on the left hand side. Multiply over here, this will be your dr over dt, the denominator, rate of change. Okay, can you see that why I write it this way? Can you see your dr and dr will cancel? After they cancel off, am I right to say that this is the rate of change of the area? This is how it works. Okay, which one do we start with again? The one without the rate of change. Put an equal on the left side, put a multiply on the right side. The one at the numerator, please put the rate of change on the left. The one at the denominator, please put the rate of change on the right hand side. And they should tally, but I'm not asking you to go and cancel. Now, whatever three pieces of information that you have previously, plug it in. dA dt don't know, we continue to write dA dt. dA dr, do we have it? 8 pi r. But do we know what is the actual value? Times 0.1. But did they tell you what is the value of the radius? 12. Yes, read the last part. The radius is 12 centimeter and give your answer in terms of pi. Meaning, you cannot press the calculator and evaluate pi. Leave it in terms of pi. So 8 pi times 12 times 0.1. I think you can press your calculator for 8 multiplied by 12 multiplied by 0.1. What would that be? Now make a guess. What would be the units of measurement over here? If its radius is centimeter per second. This is area. Cm square per second. Okay, can you please copy down this example before I move on to the second part? After I'm done with example 2, we are done already. Rate of change is just like that. Yes. It's not difficult. You must make sure you know what are the information you are required. Second part, what do they want? Volume. What volume? Yes, but they are calculating the rate of increase of the volume. What is rate of increase of the volume in mathematical symbol? D. Volume, volume, we use V. dV over dt, we put a question mark. Am I right? But we are talking about volume. Have we written out the volume formula? What is the volume of a sphere? Are we able to differentiate V with respect to R? What do we get? You realize after you differentiate, this is the area, the surface area of a sphere itself. Okay, so this is one way you can remember the formula next time. When you differentiate the volume, you get back the surface area of a sphere. We have 1. We have 2. But one more mistake. Where is that third one? It's not 4 pi r squared. No. Come on, look at the first sentence. What did they say? The rate of change of the radius. Just have to write out, that's all. Okay? There must always be 3 information. Okay? I always insist you write your 3 information. Alright? We need to find this. This was given in the question. They told you there is a volume involved. You need to write out the volume formula before you differentiate it. Now, piece all these 3 information together now for me. Yes, Kevin. Let me finish first. Very urgent? I give you a rubber band first. Okay, go. So, which one do we write first? Which one do we write? How do we connect all these 3 together? You don't know? I've been doing that the past 5 to 10 minutes. Which one do we start with first? There are 2 dealing with the rate of change, and I already insisted just now. Which one do we start with? Okay, can you tell me which is the one that does not deal with the rate of change over here? Doesn't deal with. Yeah, what is that? dV over dr. dV over dr doesn't deal with the rate of change. So look at the one. How do you know it doesn't deal with the rate of change? Don't have dt below. Yes. So start with the one that doesn't deal with the rate of change. Yes, equal on the left, multiply on the right. What do we put over here, Josiah? Numerator first, rate of change of the numerator followed by rate of change of the denominator. Double check, dr cancel, is dv dt? Yes, it's correct. Yes. Okay, that is why you need 3 pieces of information before you can form the chain rule. Now same thing, plug everything inside. dV dt, I do not know, I need to find. dV dr, I have it. But you are told the radius is 12, so straight away I plug in 12. Likewise, 0.1. Now press the calculator again. I think it's 4.8 or 12 squared. Sorry. 57. This is in terms of volume, so the units of measurement must be cm cube per second. If this question is given to you, it's 6 marks. But in reality, in exam, we will not give you twice. This one and this one is the same. The concept is the same. We only give you once. Okay? Rate of change, we only give you once. That is why I always say it's only worth around 3.